We're going to do 7.4b today. We're going to be talking more about our partial fraction decompositions. Our objectives are more PFD fun. Woohoo! Yeah, math. So let's just start right in with an example, because that's kind of all I'm going to do today. It says find the PFD. Pretty straightforward. My equation is going to be 5x minus 1 over, I guess that's bad math, it's my rational expression is this, that's a 2, minus 15. So before I start, I'm going to factor the denominator, so this is x minus 5 and x plus 3. So when I write my PFD, it's going to be a over x minus 5 and b over x plus 3. In case you're wondering, it doesn't matter what order we do these. We all tend to factor a little bit differently. What matters is the correct value is over the correct linear factor. So now I am going to multiply by my original denominator. And so on the left-hand side, I get 5x minus 1. On the right-hand side, it has the x minus 5, so it just needs the x plus 3. And then the b has the x plus 3, so it needs the x minus 5. I'm going to expand, and I get ax plus 3a bx minus 5b. And in this one, I'm going to just start by writing my equations. I'm going to have a linear equation and a constant equation. So I'm going to have ax plus bx equals 5x. So I use those three, and then 3a minus 5b is equal to a negative 1. I'm going to drop this into a matrix, 1, 1, 5, 3, negative 5, negative 1. And I'll do 1 as we start this video just to remind us of the process. So I'm going to go to second matrix. I'm going to edit. I always do A, and my A matrix is a 2 by 3. And I have 1, 1, 5, 3, negative 5, negative 1. I check to make sure that I didn't screw up my data entry. Okay, scoot it over just a little bit. And then I'm going to quit. My operation is already there, but just in case you've forgotten, so I'm going to do second matrix math. I'm going to go down and find my RREF, and I'm going to tell it which matrix to do the math on. And then I'm going to record my answers. A is 3 and B is 2. And it's just interesting to notice, because we haven't talked about it for a while, the 1, 0, 0, 1 is called the identity matrix. And if you'll notice, if this is the A column and the B column, that's why it's so handy to give me my solutions. So now what I'm going to do is I'm just going to write my solution. My PFD is equal to A, so it's 3 over x minus 5, and then my B, 2 over x plus 3. So that's a nice, polite start to our partial fraction decompositions. So the next thing that we need to do before we start the second example is factoring a cubic. And I'm going to write both of them down. A cubic is very similar to a second degree binomial, but it's a little bit different. So the cube root of A cubed is A, and the cube root of B cubed is B. The inside is going to be A squared plus AB plus B squared. Notice that in the negative, only the first term is negative, and notice that the middle term isn't doubled, okay? And then if I have A cubed plus B cubed, cube root and cube root, and this time it's going to be A squared minus AB plus B squared. Now, truthfully, I don't always remember these. I can get the first part because it's just the cube and the cube, and I know this is about what it's going to look like. If I forget, I can just do a quick expansion, and if I get something wrong, I can usually get back to these really quickly in case I have a brain fart. So for our next example, we're going to use that handy-dandy thing. Is that true? I lied. All right, our next, we're going to find the PFD, simple directions. My equation, my rational expression is 2x cubed minus x squared plus 5x, and it's going to be over x squared plus 1 squared. Now this is kind of a cool one, so I always try to pick and make sure that we do different types of examples. This is irreducible over the reals, because if I solved, I would get an I, but it's also to a power. So when I set this up, it's going to be ax plus b over the first power, and then it's going to be cx plus d over the second one squared. Okay, so it's not so bad. And then I'm going to multiply by the original denominator, x squared plus 1 squared. On the left-hand side, I get my numerator, 2x cubed minus x squared plus 5x. The ax plus b needs one of those guys, and the cx plus d needs nothing because it already has both, so they just cancel. So when I expand, I'm going to get ax cubed plus ax plus bx squared plus b plus cx plus d. Okay, you could do that in a box, but I think at this point it's just easier to write it out as a linear set of equations. I'm going to have cubed, squared, linear, and then I'm going to also have constants because they have one constant. So when I write my equations, I get ax cubed plus, there's no bx cubed, there's no cx cubed, and there's no dx cubed, and it equals 2. So actually right here, you know that a is equal to 2. So I could just write that down. Okay? Alrighty. Then I'm going to write my squared. So there's not an a squared term. There is a b squared term. There's no c squared, and there's no d, that's 0, squared, and it equals a -1. And I guess I could write the cubed and the squared. And notice on this one, now I already know that b is equal to a -1. Ooh, that's nice. Okay. And then now we did cubed, squared, so now let's do linear. I have ax, did that one. No bx. I have a cx, 0 dx, and it's going to equal 5x. Well, I have no b and no d, and I know a, right? So I could say 2 plus c is equal to 5, and so I would get that c is equal to 3. So sometimes if you just look at the math that you're writing down, it's like, oh, wow, I can do that math. All right, and then our last equation is going to be our linear. I don't have an a, I have a b, I don't have a c, and I have a d, and that equals 0. Well, I know that b is a -1, and that means that d has to be a +1 to get 0, so then I can just write d is equal to 1. So then I'm virtually done. Alrighty? And I'm out of room, so let me go to the next page and write your PFD. So your PFD is going to equal, and it was a, so 2x plus, our b is a -1 over, and that was the x squared plus 1. And then I have a c, my c is 3x plus d over x squared plus 1 squared. So it's actually not that difficult, and occasionally your systems will turn out very politely, and most of the work is already done for you. Alrighty, I have one more example for us, and then we are done for today. This one again, novel directions. Find the PFD. Again, this is all we're going to do with this year. In calculus, it is a really cool tool, and we will go back and review that when we get to that point. All right, this is a unique situation, and that's the reason I chose this one. Notice that the degree in the numerator is higher than the degree in the denominator. So before I can do this problem, I actually need to start with long division. So I'm going to put x cubed plus 0x squared plus 0x plus 2. Because remember, we have to have placeholders when we do long division. X cubed divided by x squared is x. Multiply through, and I get x cubed and then minus x squared. Okay, and then I'm going to change the signs, and then when I do that math, I get x squared plus 0x. When x squared divided by x squared is 1, and I multiply through x squared minus x, change the signs, and so then I get x plus 2, and then I'm done. This is my remainder, so I can't start. So the quotient is actually going to help us start rewriting our partial fraction decomposition. So I'm going to write this out as this particular x cubed plus 2 over x squared minus x is going to equal x plus 1 plus the remainder, which is x plus 2 over x times x minus 1. And if you'll notice, this is this original divisor. So when I do my partial fraction decomposition, I kind of ignore this part of the term, and I only do the decomposition on this piece. So then if I start that, it's going to be a over x plus b over x minus 1. I'm going to multiply, I'm going to circle that so I don't forget it, and I'm going to multiply by the original denominator. And so I'm going to get x plus 2 is equal to a times x minus 1 and b times x. I'm going to expand my equations, so I get x plus 2 is ax minus a plus bx. I'm going to write my equations. I'm going to do the linear first. Ax plus bx is x, and then my constant, a negative a plus 0b is equal to 2. And so right off the bat, did I write that down right? Yes. So right off the bat, I can see that a is going to equal a negative 2, okay? And then I can choose to do RREF, or I could choose to solve it by hand. Either way, if I do it by RREF, this is going to be 1, 1, 1, negative 1, 0, 2. Your choice how you choose to do the problem, but you get A is a negative 2, negative, and B is 3. So now when I write my partial fraction decomposition, it's the original piece, this was the quotient from the long division, plus a negative 2 over x plus my 3 over x minus 1. And that was why this particular problem was a little bit unique. So before you start just doing math, always make sure that you look and assess to see if the problem is a little bit different than the ones that you've done in the past. All right, that's it for today. I will see you soon.